So remember, the idea is area, calculus finds area under a curve by rectangles. And please read carefully. There's a difference between area under y equals 4 minus x squared in the x-axis versus, actually, area, let's say area, I'm going to say this is area between y equals x squared minus 4 in the x-axis, and compare that to just, hey, here's an integral, negative 2 to 2, x squared minus 4, evaluate. Okay? Those are two different questions. There's a ton of overlap between the work, but they're not the same. If it says find the area between, then it must be positive. Okay, it's got to be positive. And you have to take steps then to manipulate to change that. If it just says, hey, here's an integral, find the integral, or hey, here's a velocity, well, how fast is it going, or how far is it going? Negatives are in, and negatives are left. So this, negatives are okay. If it just says evaluate the integral. Okay, so distinguish between all integrals really are area in a fashion. It's just how are you using it or what are you trying to find, right? Remember that rectangles are where the fundamental theorem comes from. The whole idea is these are bases times heights. If you see slices go this way, then that means this is a small delta x for the base, and therefore you're going to integrate with respect to x. If, for whatever reason, we'll talk about in a second, you were to draw rectangles this way, so if you draw rectangles this way, then this small thickness is more like the height is delta y becoming dy, and you're using y as the. So draw and say, what are my slices? What's x versus y? Now, in terms of choosing x versus y, there's a lot of things that go into your head. Are the equations already in terms of x or y? Another might be which is easier to integrate. Tangent versus arctangent, for example, or sine versus arcsine, b versus log. Which one would I rather integrate? Okay. Another is one region versus two. Draw this little picture here. Say you had this little square root function for a while, but then it got chopped off and made a line here. If I was finding the area of region R, and I used x slices, would those x slices go up and down or side to side? Up and down. And would I need one integral or two? Two. If I use y slices, then the slices go side to side, and how many integrals? One. Okay, so that would go into my mind too. What's easier, all right? Keep in mind also that there are sometimes you're going to get two areas. If, for example, you had something like that, then that has to be done with two integrals, one totally different or upper minus lower than the other. Okay, different upper minus lowers. You follow? You couldn't just slap a, you actually, for the advanced of you, could you slap, say the intersections are A, B, and C? If you had a calculator, could you give us a one integral? You could have. If you slapped absolute value on this, if you took f minus g and slapped absolute value on it, it would work no matter what because the height being negative in the chunk would never happen. I would prefer you just say, I'm just doing it 2 integrals, okay? You with me? Okay, calc or no calc, please, I beg you, even if it's calculator, you still need to show all intersection points to 3 decimals, and store no calc. There are going to be some times where you're going to have to find an area without a calculator, and it's a ton of arithmetic, not terrible arithmetic on the AP test, but there's going to be, you're going to have to add fractions. sorry to break it to you. You're going to have to be able to add and subtract numbers, okay? Last but not least, are you positive? Area should be positive. An area is made positive because you use right minus left or upper minus lower. If you do that, you'll always get a positive answer. If you're not getting a positive answer, you need to figure out why. All right? Let's talk volumes. There really are two families of volume problems, revolution and cross-sectional volume. There are three types of revolution problems. If you would, draw yourself a little sketch. And would you make a slice perpendicular to the x-axis that touches the x-axis? If you get a slice like that, and you revolve it around the x-axis, then what's made? It's a disk. And the disk is volume is pi r squared times h, and the h is either dx or dy, depending on how it's revolved. In this case, in my picture, would it be dx or dy? That would be dx, okay? Now would you draw yourself a little graph and make a little slice just like that vertically, but make it above the axis. If you took that and revolved it around the x-axis, then it would have a mirror image, and connecting would look like that. In that case, obviously, you get a washer, the volume for which is pi big R squared minus little r squared times height, and again, the height is either dx or dy. Okay? And then last but not least, if you draw a graph and maybe draw that same kind of first slice, but this time if we revolved it around the y-axis, well, the mirror image would be that, and then you get a shell, the volume for which is the sum of 2 pi r for the circumference. That's the idea. It's an unwrapped rectangle where the bottom edge is 2 pi r if you unwrap it like a piece of paper, and the height is the height. Okay? All right. Using the axis of revolution, I beg you, make sure that you consider what is it revolved around. It will usually say, if it's a free response question, revolved around the horizontal line y equal 2 or the vertical line x equal 2, but it has been the case that sometimes they didn't add in that little horizontal or vertical. You've got to, check, double check, and triple check before proceeding that you are revolving correctly. If it says revolve it around y equals 2, and you say, okay, so here's y equals 2, you have no chance. You will get no partial credit. None. Okay? That has got to be nailed. If you go off in that direction, you're looking at wasting 15 minutes for a 0. You've got to make sure that you have that right. Okay? Verify. Basically, y equals a constant is, if y is the same, then that's a horizontal line, and x equals a constant is a vertical line. I know that's counterintuitive. You think y is vertical thing, but its y is always constant, so it doesn't move vertically. It's horizontal, all right? But please, again, just make sure when you do the axis of revolution, you use right minus left. So, for example, if you had a slice here, but it was revolved around -2, then you're talking more like f minus -2 for the revolution this distance, right? beg you, please make sure you use right minus left and upper minus lower. And you'll be having a chance. Okay, next, cross-sectional volume. That's when you have a figure and you can build off of it, or it could be a problem like we did in the warm-up. Here kind of deal, yeah? If it's squares, then it's just the side squared dx or dy, d something. Okay? If it's rectangles, it's a couple different possibilities, but just think base times height. And then what do they tell you about the base and height? Is the height constant? Is it twice the base? Whatever. Those could be a lot of different cases. It could be semicircles. In that case, then, it's more like pi over 8, which comes from half of a circle, pi over 2, but also half of a diameter squared. That's another 1/4. That's where pi over 8 comes. And it's pi over 8 of the diameter squared. D, whatever, x or y. And then we'll skip isosceles. It's not usually done. I hope now that I'm not misleading you. But equilateral triangles are typically from 1/2 AB sine C leads to root 3 over 4 times a side squared. Whatever. Okay? But generally, most generally, if you're going to memorize this. The volume is the cross-sectional area times the height. That's the big deal. Okay. All these are just variations of area of the base is area of a square, area of a rectangle, area of a circle, semicircle, cha-cha-cha. Okay? Just remember, volume should always be positive. If it doesn't come out positive, you did something wrong. Volume comes out positive through skill, not luck. Use upper minus lower, and we talked about that. Please, I beg you, draw. It helps. They don't grade you for your picture. It doesn't have to be beautiful, but it helps. Make double sure you're reading carefully for horizontal versus vertical. And on the AP exam, they don't read for units. So if they gave you a volume of revolution, unless they say, like, that warm-up, but now I'm lying. Because in that warm-up, they did grade for units because it had meters all over it or feet all over it. But generally, for a volume of revolution, they don't grade for units, so putting unit cubed or unit squared there, it doesn't earn you any points. That said, I should say they do look at your units, and if you use the wrong units, you do lose points. Okay? You get no points for putting them in, but you will lose points if you put the wrong ones in. So the method usually is don't do that. All right? Are you with me? Great, you're a bunch of fireballs today. Atta baby. So, here we go. Do you have any questions on anything you've ever learned in calculus? No? Great, you're ready. All right, I'll just stop the recording and leave it at that. And if you have questions on any of the reviews, let me know. Which one did I say is due today? Blue? None. No, I definitely said something. Yeah. Blue? Blue today. What was yesterday? Gold. Blue today. There's 2 yellows, sorry. So, can I say it right?
Yeah, you said the other one was the 2.
Really?
You said
Really? I'll really do it, right? All right, apparently nothing, but I will grade them as I get them and hand them back to you. So I will, if you turn them in now, or today, I'll get them back to you tomorrow, and you can have them back. Otherwise, I'll have them take them by Friday. Yes, let me stop this, and I'll be right there. Not.